We Python people love dictionaries, and in Python 3.15 coming out this October 2026, there'll be much more to love. In this video, I'm going to show you the new frozendict built-in data structure, why you should know about it, care about it, and how you're going to use it in your own code. So first of all, as you can see, frozendict is a built-in. You don't need to import it at all. It comes with Python 3.15, and it is its own distinct type. So I can create, of course, a dictionary, D equals A10, B20, C30, right? And the type, of course, is a dict. If I want to create a frozendict, I cannot use that same syntax. I have to say FD equals frozendict, and then I can either pass it a list of a list of tuples, two-element tuples, or I can even just use keyword arguments, A10, B equals 20, C equals 30, right? And so we can look at FD, and you can see that its printed representation reminds us of a dictionary, because it has the curly braces there, but it has the word frozendict, so we can know that it's different. Sure enough, if I ask what is the type of FD, it tells me it's a frozendict. Now, the type then of D equals the type of FD? Of course it does not. But does D equals FD? And the answer is true. The keys and the values are the same, and thus we get back true. So the comparison with a dictionary is the same. Well, then how is a frozendict different from a dict, other than that you can only use it during the winter? Haha. No, so a frozendict is immutable. You cannot change it. You cannot modify values. You cannot add new key value pairs, and you cannot remove existing key value pairs. For example, if I say D of X equals 999, that works fine. I've added a new key value pair to my dictionary. And if I say D of X now equals 888, that works just fine as well. I've changed the value. If I say D dot pop of X, I get back 888, and now I've removed that key value pair. But if I try doing any of those things with my frozen dictionary, it's not going to work. FD of X equals 999 says, nope, not allowed to support item assignment. You can't change the value associated with a key, and you can also not add a new key value pair. Both of those things are completely forbidden because it would mean, of course, mutating, modifying the frozendict. What if I try to remove it? FD.pop of A, not that it really matters what I pass. Once again, it doesn't even have an attribute pop, doesn't have a method. Because if I say here D dot in Jupyter tab, we will see all the methods associated with the dictionary, and many of them are kind of innocuous and for read-only, but some of them actually modify the dict itself. Clear and pop item and set default. None of those exist on frozendict. Indeed, if we see here fd.tab, you'll see many, many fewer methods. So all the methods that allow us to retrieve from a dictionary, the methods that allow us to iterate over a dictionary, its keys, its values, its items, those all exist. But the methods that would allow us to modify a dictionary, they simply don't exist. So what does this mean, right? How could we use it? Well, in the simplest possible way, frozendicts are generally hashable. Right? Why do I say generally? I'll get to that in a moment. Hashable means that we can run them through the hash function that Python comes with, and that is what is used to basically store dictionary keys, or for that matter, elements in a set. So if I try saying here, D:10, right? I'm using my dictionary, use the dict D as a key in a new dict. That won't work. You can't do it, and it'll say here you cannot use dict as a dict key because of the unhashable type dict. Can I do it with FD though? Absolutely I can. But there is a caveat here. Remember that you can also use tuples as dictionary keys, assuming that none of the elements of the tuple are themselves mutable, right? So if I were to say here 10, 20, 30, :10, right? This dictionary works just fine. But if I say here 10, 20, I'll make a little list here, 30, 10. This won't work because we have a list there and the list is unhashable. In exactly the same way, if you create a frozendict of A equals 10, B equals 10, 20, 30, and C equals 30, right? This is a perfectly legitimate frozendict, but you cannot use this frozendict, :10, as a dictionary key because it is unhashable, because it has a list in it. So most of the time, in many, many cases, especially if you've thought about it before, then yes, your frozendict will be hashable. But just as with tuples, they're not hashable always. Frozendicts are not hashable always. Okay, this raises a question. Where would you use these? Why would you want to use a frozendict? So use case one. is in the case of, config info in a module, right? You might want to have a module, for example, of the months, right? So let's say I say you might want to have a variable, or what we would call in Python a constant, even though the language does not have constants. So I say here January 1 and February 2 and March 3 and so on and so forth, right? So I might want to have this as a dictionary. But someone could easily come along knowing that Python does not have constants and say months of January equals 99, right? And now that has changed my dictionary. That's kind of bad. So instead of doing this, I can say here, I don't want it to be a dictionary. I can say it's a frozendict. And then I say here, January 1, right? We'll say here, do it this way. January, all right? And this equals 1, February equals 2, March equals 3, right? So now I've created a new frozendict. And then if I try to change it, you'll see that I get that error. Frozendict does not support item assignment. So it allows you to create dictionaries that are configurations that no one can change. It's just like impossible to do that. Along the same lines or similar lines, you might want to consider, so use case 2 is if you want to have a function with argument default values that are dicts. So basically, you might know that you can define a function, and that function can have default argument values, meaning that if you don't pass an argument, the parameter gets a default argument. That's great. We use it all the time. But if you use a mutable value as your default, bad things can happen. So for example, let's say here def score. Let's say I want to do like a Scrabble type of function. So I'll take score takes a word, and then I'll say here, right, letter values equals, and I'll say here A1, B2, C3, D4, E5, and F6. Right, so I'm going to pass this along, and then I can say here something like output equals 0 for one letter in word, if one letter in letter values. Then we'll say here output plus equal, and we'll say here letter values of one letter. Right, and then I say here return output. Nothing wrong with this on the face of it, and it will work. So if I say score of hello, it'll tell me that's 5 because it got E being hello, right? And nothing else is in there. Score of cab, it's going to say 6 because it has A and B and C. All these things work just fine. But there's a hidden danger here. This is a dictionary. Dictionaries are mutable. And so one potential problem is that if you set it in the function, that setting remains from call to call. You never ever want to have mutable default values there. And I can even do something kind of evil that you would not necessarily do, but that's possible. If I go to score and I look at defaults, that's where it's stored. So that's where score stores it. And defaults is a tuple. Default 0, that's my dictionary. So if I default dictionary there and I say A equals 999, now I've changed it. And now if I say score of cab, oh my goodness, that's pretty bad. So you really want to avoid using these sorts of mutable values as argument default or default argument values. How can we deal with this then? You know the answer. Frozendict to the rescue. I say here frozendict of, and then we'll once again say A equals 1. We'll say B equals 2, C equals 3, D equals 4, E equals 5, and F equals 6. We close that up, and now we have exactly the same function. I can say score of hello. I can say score of cab. All that works great. But now if I try to nefariously change the scores here, you can't do it. Why not? Because you cannot change, of course, a frozendict. So this allows us to have dictionaries as default argument values without the dangers that are associated with mutable defaults. One last thing that I should mention here as a use case for frozendicts is we are moving toward a world in which Python doesn't have a GIL. There's already, that is to say, you can have free-threaded Python, that where threading is going to be more and more popular, more and more useful, more and more used, because threads will actually run in parallel. That means that we're going to have a world where we have to worry about securing our data. And so while it's not necessarily true now that everyone needs to worry about this, over time, having shared values, like I showed you with that configuration of months, having shared values that are immutable, that are useful to everyone, but can't ever be modified by someone, are going to be increasingly useful also and increasingly important to ensure that our code runs securely. Frozendicts are an exciting new addition to Python 3.15. You can already try them if you install Python 3.15 with UV or in all sorts of other ways. I hope this was helpful and interesting. Tell me what you think about frozendicts, about Python 3.15. Tell me what questions you have, and I'll be back real soon with lots more about Python 3.15. And of course, as usual, Python and pandas and everything in between. I'll see you soon.